Welcome to aminacademy.com. In electrical engineering, let us discuss about some solving problem regarding effective resistance in combination circuit. Resistors in series and parallel. Resistors can be connected together in an unlimited number of series and parallel combination to form complex resistive circuit. Resistor circuit that combine series and parallel resistors network together are generally known as resistor combination. Or mixed resistor circuit. The method of calculating the circuit equivalent resistance is the same as that of for any individual series or parallel circuit, and hopefully we know to calculate resistance in combination now. Here, look at this circuit. Here, series and parallel combination is there. Here, this R2 and R3 resistance are in series. You have to calculate first R2 plus R3, 8 plus 4 equal to 12 ohm. This combined resistance in series 8 ohm plus 4 ohm is 12 ohm. Then this 12 ohm is parallel to this R4. So look at this. After that, this 12 ohm here, this become 12 ohm here, and this RA and R4 is parallel. Now 1 by RA plus 1 by R4, which is equal 1 over 12 plus 1 over 12, which is equal 1 over 6. That is, there's 1 over R effective. So suppose here equal, therefore R and 4 equal 12 over 2 is 6 ohm. So these two are parallel, together it becomes 6 ohm. That is, this is not 6, this is 1 over 6. This 6 ohm together, and this 6 ohm, and this 6 ohm and this together 6 ohm and 6 ohm is in series. So the final answer is R effective, or resistance effective is 6 plus 6, 12 ohm. So the combination have 12 ohm. Look at this. This is the final resistor, that 12 volt circuit, that is here 12 ohm equivalent. Therefore, then current through the circuit is V by R, that is 12 volt by 12 ohm equal to 1 ampere. Next, look at this resistors in series and parallel examples. This complication looks, but it is here. Find the equivalent resistance of the following resistor combination circuit. Look at here. Here, this terminal voltage, terminal resistance required these 2 points. Look at here. First, these two things, 10 ohm and 10 ohm is in series. So it becomes 10 ohm and 2 ohm is series, so it becomes 12 ohm. That 12 ohm is parallel to this R9, 6 ohm. Then all this together become one single ohm, and that single resistance with this resistance is in series. Then this together all resistance is parallel to this. So we have to calculate one by one from right to left side. Look here, this, look at these shading things. So we have to calculate this one first. So RA equal R9 plus R8 plus R10. R9 plus R9 plus R8 plus R10. R8 and R10 is in series and that is parallel with this one. This shaded combination is here. RA equal to R9 into R8 plus R10 over R9 plus R8 plus R10. This is a shading area of effective resistance of that one. So it becomes 4 ohm. This altogether gives 4 ohm. Then this 4 ohm is combined with here parallel to R6, that is 6 ohm. Look at this. Now this, suppose here we are calculating RA with this RB now. This is this shading, look at here. That means this shaded we calculate becomes a single resistance of 12 ohm. That is combined these three things. Look at here. That is RB. You are calculating the shading area of RB equal R6. R6 into RA plus R7. RA plus R7. This is a series combination. That is RA plus RA plus R7 is a series combination. That together is parallel combination of this R6. So that is RB equal R6 into RA plus R7 over R6 plus RA plus R7. That is together. This becomes another 4 ohm. This gives up to the shading area, it's a 4 ohm. Now this circuit further reduced these triangles now. So this R8 and R5 is series resistance. That series combined resistance is parallel with this R8. So the combined resistance of, suppose you consider RC equal to R4 into RB plus R5. That is RB and R5 is series, then that together is parallel to this one. So we have RC equal to R4 into RB plus R5 over R4 plus RB plus R5. So this also become this up to become it's a 4 ohm. Then the circuit is further reduced, like look at here. This together become 4 ohm and this 4 ohm, that is R3 4 ohm is series with that one. Then look at this. These are R3 and RC is series circuit. So that series circuit is combined with parallel to this R2. Therefore, RD, this is a combined resistance is RD, which is equal R2. That is R2 is 8 ohm into the combination of this one R, that is R3, 4 plus 4. RC plus R3 over R2 into RC plus R3, that is 8 plus into 4 plus 4 over 8 plus 4 plus 4, that is 4 ohm. Now this shading area is up to the shading area is 4 ohm. That 4 ohm is series with 6 ohm. Look at here. Then this become 4 ohm, that is RD is series with R1, that is 6 ohm. So that together is addition. The series circuit, that is R1 plus RD, that is effective resistance. Look, it becomes 10 ohm because 6 plus 4 ohm, that is R effective. Addition of this one, 6 plus 4 equal to 10 ohm. That this combined circuit have effective resistance have 10 ohm. Then from this we can calculate current through that one if voltage is given. Here voltage is not given, so the effective resistance we calculate 6 plus 4, that is 10 ohms. Now, simple calculation. Look at here. This circuit have two resistance in parallel. That is 6 plus 6 is are parallel. Though it is 1 over equivalent of these two things is 1 over R1 plus 1 over R2 because it's a parallel. So it is 1 over 6 plus 1 over 6 is 2 over 6. That is effective resistance is 3 between this parallel. That 3 resistance parallel series to this 3. So these are series circuits. So 6 here, 6 plus 3, 6 plus 6, 3 plus 3 is 6, and this also series with 5. So total resistance is 11 resistance because R1 plus R2 plus R3. So 6, 3 plus 3 plus 5, 11 ohms. Next one, the same procedure. This is parallel. So that parallel is 1 over 12 plus 1 over 6 is equal to 3 over 12. That reciprocal is 12 over 3 is 4 ohm. This together 4 ohm. That 4 ohm is series with 9 and 5. So the combined resistance is 9 plus 4 plus 5. 9 plus 4 plus 5 total resistance is 18 ohm. So it is 18 ohm here. The same way here 12 and 6 is parallel, then that 1 over R1 plus 1 over R2 equal to 1 over 12 plus 1 over 6 is 3 over 12. The reciprocal is 12 over 3 is 4 ohm. This is a 4 ohm. That 4 ohm is series with 6, 3 and 5. So altogether is, look at here, that is 3 plus 6 plus 4 plus 5, totally 18 ohms. Now look at these problems here. A 9 ohm resistor R1 and 6 ohm resistor and R2 are connected in parallel with each other and series with 40 ohm resistor. R3 shown figure. Determine the total resistance. Here, this together. This together, look at here. This is suppose it's 1 by 1 by RA equal to 1 by 30 plus 1 by 60. So 60 is an LCM. 2 plus 1, 3 over 60. Therefore, RA equal to 60 over 3 is 20 ohms. This altogether, this 20 ohm. The 20 ohm is series with 40 ohm. That is R effective. R effective equal to 20 plus 40 equal to 60 ohm. Now, one more example. Look at here. Here, this is series. So it's together is 2 plus 2 equal to 4 ohm. That 4 ohm is parallel to this 4 ohm. So which is together is now 1 by RA equal 1 by 4 plus this effective 1 by 4 equal 2 by 4, that is RA 4 by 2 is 2 ohms. This altogether 2 ohm. This 2 ohm is connected with this 10 ohm in series, so it is 12 ohm. Suppose RB 2 plus 10, 12 ohm. This all together as 12 ohm. That 12 ohm is parallel with this combination of series, that is here 4 plus 8 is 12, here another 12, so RC 1 over RC is 1 over 12 plus this altogether 12. This together is 12. 1 over 12 plus 1 over 12 equal 2 over 12. Therefore, RC equals to 6 because 12 over 2 6. This 6, this 6 and this 4 is all together. Now R effective now R effective is series with 4, that is 6 plus 4, 10 ohm. So all this explanation is 12 ohm. That equivalent circuit ohm is 12 ohm. So totally R equivalent is 10 ohm. Finally, later on, like this circuit is final circuit is this one. Now, suppose you want calculate current. Current is 10 ohm is resistance. V by R, that is 5 over 10 equal to 0.5 amps. Altogether we calculated. Here, like this list combination, look at here. This is first series. This R10 and R3, R9 is series. So it becomes 10, R10 is 3 ohm, R9 is 3 ohm, 6 ohm. That is first here. Then this becomes 6 ohm. This 6 ohm is parallel to another 6 ohms. So that is RB combination. This together is RB is R8 into RA over RA plus RA. That is 6 into 6 over 6 plus 6 is 3 ohm. This is with 3 ohms. That 3 ohm. Now this will become 3 ohm. That is series with 9. So 3 plus 9 is 12. That 12 is combined with this 12. There is 12 here first. That is this together. And that 12 is combined with this RD. RD that is becomes 6 ohm. That is RD is parallel of R6 and RC plus over R6 plus RC, which becomes 6 ohm. The circuit is reduced now. Now this 6 and this 6 is series, so it's become 12 ohm. That 12 ohm is parallel to this 12 ohm. The resulting circuit becomes like here, this become 12. This 12 and 12 is parallel, so that becomes RF, suppose R5 into RE over R5 plus RE becomes 6 ohm this together. This 6 ohm is parallel to this 2 series, that is 4 plus 2, and parallel with this combination. So this is, look at here, these two resistance are in series, so 4 plus 2 is 6. That 6 is parallel to this 6. So this combination is like, it is equal, then RT total resistance is RF plus into RG over RF plus RG, that is 6 into 6 over 6 plus 6, 3 ohms. This final circuit is like this 3 ohm and this 3 ohm become 6 ohm together. Let's combine. This is a parallel and that is parallel with series here. So total resistance, that is effective resistance of the circuit is 6 plus 3 plus 3 is 6 ohm. Then final circuit is like against 6 volt terminal, that is 6 ohm resistance is combined. So ampere current through the circuit is equal effective current, that is V1 by R equivalent, that is 6 by 6 is 1 amps. So far we calculated series and parallel combination circuit, that effective resistance we calculated for different types of problems. We have done. Please subscribe our YouTube channel.